All right, ladies and gentlemen, here to look at question 3. So question 3 gives us the image and the pre-image, and it tells us that the blue triangle is a translation of the black triangle, meaning that the black triangle is where we started, because the blue triangle is the translation, it is the image, it is after the transformation. And so what's the rule? Well, in order to identify the rule, like we've talked about for our vector, we want to know the x and y values. So first, let's use some purple, because purple's a great color. Let's count from any point, and this works from any point, but I'm going to choose the one that I've highlighted in purple. We're going up 1, 2, 3, 4, so that's a positive 4. And then we are going over, and I'll go ahead and mark that in green for our x value, 1, 2, 3, negative 3, because we went to the left. And so our vector then, if I draw that in, I'll go ahead and use red because bright colors are great. It's the line connecting those 2 points, but intentionally and specifically with the arrow pointing towards the image. So, ladies and gentlemen, what does that look like to help identify our vector? What's the rule? Well, our rule is the x value, negative 3, then the y value, 4, in our pointy brackets there. Perfect. Let's take a look at question 4. Question 4 is looking at the coordinate of q prime for t given the rule. And so here we're taking the shape and we're going to be translating it down 3, or sorry, not down 3, left 3, and then down 4. Sorry, before I continue, let's go ahead and select the option that we talked about a second ago, just to make sure and feel good that it's right there. Bam. And for those of you who watched the last video, I forgot to go ahead and select the answer for question number 2. So for question number 2, we got to our point that is positive 6, negative 6, x is 6, y is negative 6, x is 6, y is negative 6. Bam, results. So back to question 4. What is the coordinate of q prime for the translation? X is negative 3, y is negative 4. Well, here, I'll just count it on the graph. Going from q, we want to go left 3, 1, 2, 3, and then down 4. 1, 2, 3, 4. So what point do we end up at? We end up at the x value, negative 2, and the y value, positive 1. X is negative 2, y is positive 1. Ladies and gentlemen, here's a layer of mathematics that's essential. Paying attention to a curved versus a pointy bracket. It is subtle. It's something that is hard to notice if you're not intentionally looking for it. But I know this is a point on the coordinate grid, a specific dot, because they are curved brackets. I know this is a distance and direction, that this is how far left and right and how far up and down, because of the pointy brackets, right? So how the brackets are written intentionally tells us what its purpose is, and they're very, very similar notations and mean radically different things. So, ladies and gentlemen, question 5. Once again, select all the descriptions that apply to the transformation, so we're identifying the rule once again. First, where's the image? Where's the pre-image? All right. Give you a moment to think about it. While you're doing that, I'm going to go ahead and put these onto our fantastic Kami document. All right, ladies and gentlemen, so for question 5, first we need to identify what is actually happening. Well, we can say with confidence that it's sliding, so yes, this is a translation. Second, what's the vector? How far and in what direction? Because it's on a coordinate grid, we will describe the vector with those pointy brackets, talking about the x and the y change. And so, first things first, the x change from A to A prime, because notice that's our pre-image where A is at, and then our image is where A prime is at. And so, there's our arrow to represent our vector. The x change is going to the left 1, 2, 3, 4, 5, 6, 7. So that is a negative 7 for our x component in our vector. Then the y component, the y part. So we're going 1, 2, 3 down. Voila! That is our component for the y, component for the x. That is our vector in the correct notation, right, with the pointy brackets. But what does that actually mean in English? Well, in English it means 7 down. What am I saying? Not 7 down. It's not like I haven't had enough coffee within the last 12 hours or something. 7 to the left. And then 3 down. And then down below, since this is a multiple choice question, multiple answers, we're able to select all the things that are true. And so what's true? This statement right here, -7, -3, because that is our left and down. And then in English, 7 units to the left, 3 units down. Those are our 2 correct answers. Ladies and gentlemen, let's take a look at question 6. Question 6 here doesn't give us a graph, it just gives us the components. It just gives us the language. And ladies and gentlemen, that little dot there, let's explain what that little dot means. So, ladies and gentlemen, question 7. That little dot, that little open circle means a composition. So, another way to think about it is that some of you have a composition notebook. Just to help illustrate, if you've never seen a composition notebook before, bam, composition notebook right there. Ta-da! Oh, I didn't want to open up the web page. I just want to look at the notebook itself. So why is this called a composition notebook? Because it's collecting things together. It's putting things together. Okay? So a composition notebook has all those pages in it where all those pages can be in one spot together. So what's happening then with our translation? Well, we are composing that. Think about when you do something in band, you're making it, right? You're composing 2 translations at once. This translation's going 5 to the right and 2 down. This translation's going 1 to the right and 4 up. Ladies and gentlemen, if you do multiple translations, all that really means is you're adding and subtracting them together. So, ladies and gentlemen, let me go ahead and help give that a little bit more concrete of a description there. Ladies and gentlemen, if I just pick my favorite arrow and I go from this point, well, that's not a straight line, from this point to this point. Ladies and gentlemen, it doesn't really matter what I'm going to name these points. What matters is what I just did. So I went 4 to the right, and I went 3 down. So this vector can be described as 4, -3. If I do another vector now, and I start from where I ended, so I'm doing another vector in order, right? Then I can go ahead and do a vector. Let's do it here in gray. This new vector went up 2 and to the right 3. So to the right 3 and up 2. What I just did is I just composed 2 vectors together. So if I use that same notation that's here in this new spot, then my black vector, my black translation went up 4 and over 3, and I'm composing that. I'm putting it together with my new vector that went over 3 and up 2. What does this all mean? Well, ladies and gentlemen, where do I end up? What did I actually do? Where did I originally start versus where do I end up now after everything is said and done? Well, if I were to do all of that in one step, how far over and how far up and down did I go? Well, I went over 1, 2, 3, 4, 5, 6, 7. I went over 7, but in the end, I only went down 1. So this new translation, the translation that could have been done in one step, but instead I did in 2 steps, actually is over 7 and down 1. And ladies and gentlemen, how can we actually tell that we went over 7 and down 1? If you notice, 4 plus 3 is our 7. I just added the x values. And then for the y values, negative 3 plus 2 is negative 1. So, ladies and gentlemen, what I just did is I modeled it in 2 different ways. You can either draw a picture or you can use some algebra. Either way will work excellently, perfectly, and still give you the right answer and still give you the answer you're looking for. So let's work out number 7 in earnest. Number 7 has a vector 5, negative 2. So we're looking at the translation. 5, negative 2. And we're composing that with the translation of 1, 4. So ladies and gentlemen, what do you actually end up getting? Well, I'm going to show this with algebra for the moment. Know that I could show this with a graph as well, so please ask during our live session or via email if you want to see that more specifically. 5 plus 1 is going to be our x, and then our y is going to be negative 2 plus 4. And so, ladies and gentlemen, our new translation here is going to be the vector 6, 2. Boom, 6, 2. Ladies and gentlemen, our last question here is question 8. All right, ladies and gentlemen. So, on question 7 here, what we have, wait a second. Oh, I miscounted. Oops. The previous one was question 6. So, I'll fix it. Perfect. So, on question 7 here, essentially what it's asking us to compose, so we're putting together this R notation, which means reflection. And if you didn't already guess, we're reflecting over the x-axis as it's labeled, and then we're translating by 1 on x and 2 on y to get from our pre-image to our image. So, ladies and gentlemen, we talked about reflections in the last week's lesson, so we're going to apply that here. I'm going to go ahead and use the gray. Actually, I'll use blue since I started with blue here. Blue is a great color. So reflection is all about how far away are we from our line of reflection, and then being able to count that out for G prime. And so, first things first, G is down below, which means we're going 1 up for G. Now, F is up 1, 2, 3, 4, 5. So we're going to want to go down 5 in order to get F prime. And then for E is only up 4, so we want to go down 4 in order to get E prime. So ladies and gentlemen, that is our reflection tackled and knocked out of the ballpark. Now we are translating over 1 and up 2. And here you can see in purple I've translated over 1 and up 2 for all 3 of my points. And you can see here G prime is at -1 and up 3. And so, what are the final coordinates of G prime? -1 up 3. Same thing is going to be true for E and F. E prime over here is going to be at -4 and down 2. And so that's going to be this first option right here for that point.